I'm very excited to be here. Thanks again to all the organization team to make that possible. It's really great to be here in person again. I'm going to start immediately with our giant female. I choose Farah Ali Bey. She grew up in Quebec, where I live. She's exactly my age, and that's pretty much all what we have in common, because she had a great career. She has a great career. You all heard about Perseverance and her role when Perseverance landed on Mars. There is no GPS on Mars, that doesn't work. There is no maps. And her role is to make sure that Perseverance doesn't get lost. So the only way you have is the time and the position of the sun. So she was the first one who had to send some commands to Perseverance when Perseverance landed to get the real position of the rover, so then they could orient the antennas into the right direction and start communicating with the Earth. I find her very, very inspiring. And I think that any young woman interested in science and technology, seeing that career, should also be inspired and think that this kind of awesome career is not reserved to males only. If you are interested, if you work hard, and if you meet the right people, everything is possible. All what you wanted to know about LabVIEW and Web Services, but fear to ask. Well, now that I read that, I realize it might be a little bit ambitious. Thanks, Fab, for coming up with that title. We'll see if that works out. I have some pool at the end, and you'll tell me if I did right or not. You can take a picture right away. That's the link. Don't try it. There is nothing now. But eventually, there will be the recording, the slides, and everything, so you can check the presentation again later. Okay, so everyone knows me already, right? So we can skip. If you don't, too bad. We don't have time. Okay, LabVIEW development consulting training, blah, blah, blah. Okay, I can, this one brings a little bit of money, so I can make a stop. PLT for LabVIEW, my main product at StudioBuds. It's a toolbox that allows LabVIEW developer to beacon, let you build license track applications just with a few clicks. So it's the easiest and fastest way to go from a simple LabVIEW application to a deployed license application that reports error remotely and has automatic updates capability and much more. Controls generator for LabVIEW also, if you want to try it, to generate controls from pictures. So the agenda for today, if you ever attended one of my presentations, you know that I usually have like 3 hours of content. Today it's the same. So we're going to have to make some choice at the end. We are not going to be able to see everything. So statically, probably at least 50% of the audience will be disappointed. I'm sorry in advance. So web services basics, you'll see that. Then you'll have to choose between call existing web services from a LabVIEW application, web service client from LabVIEW application, or implement your own LabVIEW web services in LabVIEW, of course, and some useful tips and resources at the end. So we'll start, if you can all take your phone or laptop and go to this bit.ly/GDevCon vote. And there is timer at the top. So you have a few seconds to answer that question. It should be mutually exclusive answers, okay? You shouldn't think between 2 answers. Hopefully you don't answer the last one.
Next time, make a QR code.
I thought about it, but I was like, I didn't know it was a huge screen like that. Is it going to work, scanning from the back of the room? I don't know. I could have put that on Discord already. I'm learning.
Did you build that with LabVIEW?
So it's real testing. I don't have 150 friends to test. So you test. Does that kind of work? Still loading?
Still loading.
So that's very slow then. Okay, I'll give it a few more seconds, and otherwise you'll just raise your hands. Someone can tell me once it's loaded. It's loaded.
You got it.
Okay.
One vote.
Let's look at if we get some results. Okay, it's coming, it's coming. Some people want to take a nap. So it's kind of balanced. Yes, no, pretty much same results. So yeah, this is written in, the front end is a G-Web development application, communicating with LabVIEW Web Service application, and there is a database to store your results. I'm cheap, so I didn't want to purchase a commercial solution, which are usually limited to 25 people in the room. So I was like, okay, let's do mine. Okay, thank you for your answer. So it's pretty much balanced, so that will help me to target a little bit more the content of today. I have another question for you, and now I'm controlling your phone. It should change the question right away. Amazing. Not for everyone. If you have an iPhone first. So refresh the page, Fab. So have you ever implemented your own LabVIEW web service? A few people had already. Most of you didn't. This is what I probably expected. And 3 people still want to sleep. At least they are consistent. Oh, 4 now. Okay. I'm getting boring. Okay, thank you for your participation. There will be more questions later. Web service basics. So what is a web service? That's a good question to ask. Thanks to Piotr that gave already an introduction to that topic earlier this morning. So it's basically any software, application, or cloud technology that provides standardized web protocols to interoperate, communicate, exchange data through the internet. So it's an application-to-application communication and interfacing. The nice thing is that application can be written in any language, and they are still able to communicate via web service between client and servers. So it's very simple. You have a client, it sends a request to a web service, the web service processes the request and sends a response to the client. Okay, very straightforward. That's some of the basics. There are various types of web services. It's a non-exhaustive list. gRPC, you probably heard a lot about gRPC recently. It's going to be natively available in LabVIEW. And REST, which is probably the most well-known web service technology today. There are 4 architectural constraints to REST. So REST means for representational state transfer. So state means the data. Representational means the format, such as XML, JSON, format that you use to communicate. And transfer means something to carry out the data. So HTTP, for instance. With REST, you need to have proper identification of the resource. In the URL of your REST API, you should already know a little bit what you are addressing. Manipulation of the resource. You can usually create a resource, edit a resource, update a resource, delete a resource that you can do with REST. Self-descriptive message. When you get an error, there is usually a description. The error code is not sufficient. There is usually a nice description of the error. So it's kind of self-documented by itself. And it's a stateless protocol. You don't have to agree with all that, but that's the definition. I've seen some REST APIs that maintain some states. So stateless means that when you call a web service method, the server shouldn't know about what you did previously. You should give all the information for the server to process your request. So web service APIs that adhere to that constraints are called RESTful APIs. So the REST architecture, again, a client, a server, a client, it can be a mobile app, it can be a desktop app, it can be a web application. And there is a server, service provider, that runs a web server, and inside that web server there is a REST API. The client sends an HTTP request. There is usually a database where the server can get some data or fill some data, and it sends an HTTP response. And there is a message exchange format that you have to choose. Usually it's XML or JSON. Those are the most popular. The components of an HTTP-based RESTful API are a base URI. So we saw that earlier in Piotr's presentation. An example is api.example.com. And to that, you're going to add some endpoints. So the endpoint references a resource or a collection of data. And a REST API might have multiple endpoints. And then you use a standard HTTP method to call this base URI added where you add the endpoint. So here I listed the 4 most common HTTP methods, the ones that are available in LabVIEW. There are others like patch, options. But those are the 4 main HTTP methods that Piotr already described this morning, so I'm not going to spend more time on that. I'd like to show an example of a REST API documentation, if I can get my mouse to work. Okay, like that. So Paymo, it's a project management system like Jira, but I like Paymo a lot more. So, where is the cursor? Okay, it's there. So it starts with some, description and how you make a request. So you can see the base URI here that I mentioned, some example. Then it will give you some hints on how to authenticate to this API. What about response codes, what you can expect when there are errors. And then you have all the endpoints. So this is a project management system. So you have endpoints for clients, for invoices, for projects, for tasks, task lists, time entries, etc. So those are individual endpoints where you can then do some get, post, put, delete request to create, update, insert, delete some data in the system. Let's continue. So let's see some example with some LabVIEW code. So an endpoint, for example, called collection. Then you're going to have a URL that looks like that, HTTP API example.com/collection. If you do a get to that URL, and you can see the LabVIEW code, you're going to get the list of all the resources member, of the items member of that collection. So this is an array formatted in JSON. Now, if you do the same to a resources member of that collection, such as item 1, so the URL now looks like that. You do a get to api.example.com/collection/item 1. And here you're going to get the representation of the item 1, again as a JSON string in my example. Now let's see how it looks with a put. Put, in this example, will create the collection if it doesn't exist, and it just returns an empty collection because it was just created. And now if you do the same on collection/item 1, it's going to create or update the representation of that item 1. So you, in the request body, you pass the value of item 1, and it returns also the same information. Okay, so that's some examples of the basic of web services. The headers are very important. This is the HTTP client palette that you have in LabVIEW. And if you look at all the VI that we mentioned for the get, put, post, delete, they all return some headers information. Headers look like this. There is HTTP, the version of the protocol, and then there is a number, 3-digit number, and a description for that number. That number is the status code of the request that you've made. And that's how that's kind of the error code. That's how you know what happened. Did it work or not? Why? This is another example where you get 401, which means you're not authorized to call this web method, where 200 means okay. This is very important that you look at the status code. It's like the error out terminal in any LabVIEW VI. They are classified in 5 categories: informational response. If it begins with a 2, it's a success. 3, it's a redirection. 4, it's a client error. There is something wrong in the request that you've made. And if it begins by 5, there is a server error. The server, for some reason, was not able to process your request. Some examples of probably the most popular status codes for web services: 200, OK, 404. You all know this, 404, page not found, resource not found, 500, internal server error. Then you can go with 500, 1, 2, 3, with more descriptive messages, maybe. So that's very important to look at those status codes. It's a very important part of the web services communication. So again, back to this diagram, LabVIEW can play a role here in a desktop, writing a desktop application as a web service client. But LabVIEW can also play a role on the server, writing your web service API using LabVIEW. And there is GWeb development software. If you want to write a web service client, a web front end that calls existing web services, you can use GWeb development software. So now you have to choose, okay? Do you want to see the part about client or server? So far, it's really, seems to be interested more in the server part. I would probably be the same. So, just so you know, the other part that I'm not able to give today because of the time constraint, I'll either do a webinar and post it on my website. I also submitted that to the GLA Summit, so if it gets accepted, it will be live during GLA Summit in November. So I think we have a clear trend, and we will continue with develop your own LabVIEW web services API. Thank you for your participation. I should be able to click on that. Oh, here. No. No. So we're going to do the old way. No. All right. Web services server from LabVIEW. I'm not going to teach you how to write web services server from LabVIEW. I'm sorry. I'm just going to give some tips. I wrote a lot of web service application, pretty large web service application with LabVIEW, and obviously I learned a lot of things from that. So again, we are playing in this part of the architecture. So today I'll give you some tips that I learned. The first thing, design a right resource hierarchy. As I say, the REST web services are self-descriptive. So by looking at the URL, you should already know what you are going to do. So if you do a get to v1/account, it's clear that you expect to retrieve the current user account data. And if you add an ID at the end, you're going to retrieve the specific user account data. If you do a post, then you're sending data, you are going to create a new user account. And if you do a post to v1/account/update/email/ID, that's pretty clear that you are going to update the email field of that specific user account. So make things easier. You are writing this probably for other developers using other languages. They don't know anything about LabVIEW. They just want to use the API that you've made. So you can do that with LabVIEW. If you go to the web service properties, you can customize the URL here. By default, when you create a web service method, it just takes the name of the VI, and that doesn't really make sense. If you have spaces in the name of the VI, it replaces with an underscore. That's not pretty. So do that. Namespace your API with a version number. You can see this V1 at the top. And if you look at Microsoft Web Services APIs or Google or any popular, it's usually always in the documentation, you're going to see a V1, V2, V3, or beta or something. That allows you to maintain the current web service that you have while still developing the new version of your web service. So you maintain backward compatibility. You cannot really shut down your web service because you decided there is a new version. There are maybe people out there that are using the previous version of your API, and they will be very disappointed if you shut that like that. Make your web method VIs reentrant. I don't know why, but when you create a web method VI, by default, it's not reentrant, and it should be, because if you want multiple clients calling this web service method, then it has to be reentrant. Okay, so simple tip, but it's not the default behavior, so you have to think about it. What I do usually is I create a VI template for my web method, and I just create everything from that template, and then I have all the VI settings that I want. Always use the stream output type. By default, you create a web VI method. It's going to select this, it's going to select terminal. And then you let LabVIEW format what you wire to the terminal in JSON or XML. So if you have a big cluster, LabVIEW is going to do some fancy JSON formatting that you don't have any control over it. So don't do that. Always use the stream output, and then you use the write response VI that is in the web service palette, output subpalette. And you do your own formatting of your data, your cluster, your class, whatever, into a proper JSON or XML string. So you keep the control on how you send the reply to your clients. There are a lot of good LabVIEW built-in features, but not all of them are good. Process the web request using oriented object programming. I found that it's easy when you develop web service application to have the VI for all your web application, because a web service method, you cannot make it part of a LabVIEW library. Then you start implementing this, and it becomes the VI. I solved that problem by using OOP. So I have a core web request class, and that's my process. So that's my core class, and any web method VI inherits from that, and we'll go through these 11 steps, which are initialize web request, add some CORS headers that's needed for web clients, check if SSL is required, check if HTTP session exists in case you use authentication. We're going to talk about this later. Check the request permissions. Is this user allowed to use that request? Check the inputs. Is it a valid request? Check the item that you want to manipulate. Does it exist, or do I need to create it, or do I need to send back an error? Check additional permissions, prepare the additional data, prepare the SQL query, and then process the request. So with those 11 steps, I figured out I was able to solve all my problems anytime I have a web application to write. These 11 steps fits what I need. So maybe you can borrow some stuff there. And in terms of LabVIEW, it means a web request parent class that has all these protected methods. And then for every web method VI, I'm going to create a child class that inherits from that parent class and just override what I need. So for example, get web service version. So you do a get method to v1/version, and you want to get the version of the web service. So my web method VI is just that perform web request VI, which is the code that you just saw earlier. And I replace this class constant with my child, my override. And I'm going to use dynamic dispatch just for what I need. So for example, the check HTTP session, I don't need any user to be logged in to check the version of the web service. So I just return true, yeah, the session exists, I don't need to create a session. You're already logged in or not, I don't care, just move forward. And process requests, then I'm going to use the read service attribute to read the web service version, format that into a JSON string, set the content type to JSON and write the response and return the 200 error code. So I just need to override these two methods, and otherwise it's using the default behavior of my parent class. So I found it really helps me to have code that is easy to maintain and to augment. The cookies. So I use cookies for authentication. A cookie, it's basically it's a session. The nice thing about cookie is that by default, any web browser, when it receives a cookie ID from the server, in any subsequent request, it will always send that cookie. So then the server can recognize a particular client. So for instance, if I want to log in on my web service API, I'm going to do a post request to v1/session, and I'm going to send my credentials. Okay. Then the server will look at some database, validate the credentials. Okay, good credentials, perfect. I'll create the session using that VI of the palette over there. And then I'll send 200, okay, we are good. If it's not okay, I'm gonna send 401 unauthorized. And you can look at Wikipedia, the description of the error codes, it's all there. And you send the response. So now this user wants to access a protected resource. So it does a GET request to v1/account to retrieve the current logged in user account data. Okay, does the session exist? This is one of the VI of my 11 methods. If yes, fine. I prepare the response, get that from the database, format this as a JSON string, and send that along with the 200 OK status. If the session does not exist, that means that you're not logged in, okay? So I return 401 authorization required. Do your job and go do a post to v1 session. And I send the response. Okay, so cookies are really convenient for providing authentication to your web service API. This slide, the idea behind this slide is just to tell you to have a standardized way on how you send the responses to the web client. So that code runs for every web method VI in my application. So anytime someone makes a request, there is this code that runs, and it basically looks at the incoming error, and if there is an incoming LabVIEW error, then I return a 500 internal error. If not, I just pass through and I return the HTTP status, and I do some logging into I log all the calls to my API, and if the status code is above 400, that means that there is really an error, so I format my JSON, my error into a JSON string that anyway. Just to tell you, have a way that every method in your API will use to have a standardized manner of replying to a customer, whether there is a client, whether there is an error or not. Logging. Web services, it's a headless application. There is no UI. It's run on a server, and if you don't do some minimal logging, you don't know what's happening. So I have 3 different levels of logging in my web service application. The event logging, where I log everything that happens in my internal modules running the application. I have some HTTP logging. Every time someone makes a request to my API, I log the IP address, what is the method, what is the browser. So then if I need to troubleshoot something, I can go to that log and get a lot more information. And of course, I have error logging as well. When there is an error, it logs the error in a separate file, so it's easier to check. So you can get a lot of information with the read request variable VI, such as the remote host, user agent, some stuff. So feel free to use that to grab that piece of code and do some logging for every call of your web method VIs. That's, I believe, all the tips I have to share for web service applications in LabVIEW. Again, the purpose was not to teach you how to do that. There are plenty of resources available on the web, just to give things that I've learned. Now I have some other useful tips and resources for you that are valid both for the client part and the server part. Testing and debugging with Postman. Postman is a really great tool. Okay, whenever I want to use an existing web service, I start with Postman. Like when you get a new DAC device, you start with Max and you make sure that you are able to communicate, to do some basic stuff before you write LabVIEW code. Same thing with web services. Postman, it's a web service client that allows you to do get, post, put, whatever, authentication. And the same when I write my own web service API, in order to test what I'm writing, the server API that I'm writing, I use Postman as well. Documentation, it's important. You are going to provide a web service API to some users, developers using other languages. They expect to see a documentation in a certain format. Swagger.io allows you to use a simple textual syntax that generates a web page that contains the documentation of your web service API in a way that other developers expect it. You can even have some try it out from the web browser, so that's really convenient. Online JSON viewer, you're going to do a lot of JSON if you write web service applications, and looking at a raw JSON string is not always nice. There are other JSON viewers online, but I like this one. You pass your JSON string and it gives a visual representation of the structure of the data with the data types and the nested objects. So it's very useful, I find. If you write a web server, you probably want to put some security on it. So keep it simple. Okay, you can do very secured stuff with simple methods. If you try to make it overcomplicated, you are going to leave a hole somewhere, and it doesn't help, finally. Always use HTTPS. Then you get the benefit of the SSL encryption, and then you can transfer sensitive data over the HTTP protocol. So that is my recommendation as well if you want something secured. In my example, I show in the post request to create the session that the user were sending the username and password, clear text. Don't do that. Use password hash, okay? And then on the server, you compare the hash that was stored on the database and the hash that was sent by the user. And that's enough to know if the password is good or wrong. So if your database gets compromised, at least you don't disclose your user's password. Never expose sensitive information on URLs, because as you saw, I'm logging all the URLs that you call on my API. And pretty much any web server does that. So you don't want to put sensitive information in URLs. And validate the request parameters on the very beginning of processing your request. Make sure that they provided what they needed to provide to call this request before you reach the application logic. Zapier, do you know about Zapier? I like Zapier. It's like if this, then do that. There are other alternatives, but I like Zapier. Zapier, basically, you specify a trigger, and then you set an action. So for example, you connect Zapier to Jira, and you specify a trigger. A new project was created in my Jira instance. And then you can set an action. An action can be called that URL. And that URL is actually a LabVIEW web service that is going to create the repo, script the project with the name of the customer, do all that kind of stuff. So you can use Zapier to create some communication methods between LabVIEW application and other popular cloud services such as MailChimp, LinkedIn, Google, YouTube, whatever. So yeah, Zapier, you can do very cool stuff. Web services are everywhere, okay? Just search for them. Don't reinvent the wheel. If you want to do some translation, don't write a translator in LabVIEW. Use Google Translate. There is a REST API to do that. BLT for LabVIEW has REST API to create licenses, MailChimp, everything. This slide is more for the client part, but don't reinvent the wheel. There are a lot of web services available, and you can just use them from your LabVIEW application. You'll learn that in the part 2 of this presentation. So this is the last vote of this presentation. If you are able to vote, just to learn a little bit what you learned from this presentation.
Oh, they're totally gone.
So cool. It seems that everybody, except the one who slept, learned something. It's balanced. A third of you learns a lot of things, and they are eager to try it. So thank you very much for that feedback. It's really exciting for me. It gives me the power to continue doing this kind of presentation. You can continue to vote, by the way. I'm just going to move forward, but you can continue to vote. In case you didn't take the picture at the beginning, one last time I put the bit.ly of the link where you're going to be able to download the slides and watch the recording. Thank you very much. It was a pleasure to give that presentation, and it's time for questions.
Such a question. At the beginning of your presentation, you said about making your service reentrant, making your service reentrant.
Yes.
To do multiple connections.
Yes.
Is there any way to limit number of multiple connections?
Not any built-in way that I know. There are some, actually in the web service configuration file, there are some INI keys where you can limit the number of simultaneous connections, but it's going to apply to all the web methods in your web service application. Then if you want to do some limitation, different limitation for particular methods, then you will have to write the code that does this kind of check. But there is, yes, an INI token in the INI web server configuration that you can use to limit that for the entire web server.
Is there any kind of rate limiting built in? Or have you experimented with that at all?
I don't think so, but I'm not 100% sure of that answer. That's something I will need to look at more. Again, you can always implement your own stuff, but built in the NI web server or LabVIEW application web server, I'm not sure of the answer, sorry. We have a question at the top over there.
1, 2, yeah. Even though I have slept through all the presentation in here, yes, I have heard a little bit you're focusing on the web service itself or the client itself, but do you have any good guides or suggestions from your experience how to decouple the web service from the main application that is actually running in the background?
Yes, we had this discussion earlier with Piotr, but what I'm doing is the application that runs in background and the web service application for me are two different projects, two different LabVIEW projects, two different repos, maybe different people working on each project. And then I use some communication mechanism on the local computer to exchange data. Usually I use JSON RPC over TCP/IP, but there are other ways. But I like to decouple like that. I usually not have the same LabVIEW project for the main application and the web service application. I learned from Piotr earlier today that there are some, basically you can have a project for your LabVIEW application, an order for your web service application. And if you put the web service file and the NI web server config file in the same folder as the exe, it's going to run the web service in the same instance. So you can still have separate projects and have finally both run in the same application instance. I didn't know that. That's convenient, I believe.
Thank you.
Matthias, is there any way to use other third-party web servers for this, or do you have to go with the NI web server?
So first, I don't use an iWeb server. I find this is an immature product at the moment. So I still use the legacy LabVIEW application web server, what they call. I don't know of any way of hosting your LabVIEW web services in any other web server technology than the LabVIEW web server or NI web server at the moment. Just so you know, NI web server doesn't support sessions cookies. So I'm not willing to move to that technology until it supports it.
So any advanced things that you might need, like load balancing or whatever web servers, modern web servers are capable?
You can always use a load balancer, physical load balancer before your server. So there are ways to manage that. But yeah, you cannot use the load balancing feature of an Apache web server, for example. You're right.
Okay. Thank you.
Okay, this is going to be completely, I'm throwing a ball at you, but can you tell them of examples of applications that you have written in LabVIEW that normally this audience would not expect for them to be written in LabVIEW? Because I think that will add credibility to everything that you just said if they learn of the crazy stuff that you have made in LabVIEW.
Which one are you thinking about?
Like the project management stuff, the accounting stuff.
Yes, yeah, project management stuff. I have some web service. So I use Paymo as a project management system, like some of you use Jira or other stuff. And Paymo has a really nice API. At the moment, there is a lack in Paymo of customer login. So customer can log into my Paymo system and see which task I'm working on, how much time I spend on it, see some reports on the hours, see the past invoices, etc. I know it's in their roadmap, it's going to come, but in the meantime, I needed it. So I created some LabVIEW web service application that uses the Paymo API to do what I wanted, and then I wrote another front end only for my customers using GWeb development software, so my customer can log in and see exactly where I'm working, which particular task. They can create new task for me, assign that to different team members, see how much time I spend on this task, etc. So I'm very transparent to my customers, and it's really valuable to them. So yeah, that's an example. Another nice application is, so when you call StudioBots, it's just myself and some contractors, but you call StudioBots by phone and then you need to enter your service request number, blah, blah, blah. So in the back, there are some web services that use the VoIP system and that are going to check again my Paymo system. Oh, is it a valid request? Is it in progress or not? And then it always assigns the call to myself anyway. But I found it was really cool to do.
Eventually.
Is this on? Okay. I have I don't want to cut into Christian's presentation, but is there any limitations to running this inside like a Docker container or something if you're doing web stuff like that?
So LabVIEW Web Services, it's Windows or RT, Linux. I don't have much experience with web services on Linux RT. Pretty sure using the Linux RT web service version, you can do something with Docker and put that on some container. This is something I never really tried. I realize the potential of Dockers, but I put a lot of dollars in a really nice ESXi server where I can run more than 40 VMs at the same time. I'm fine with that at the moment.
I have a small comment on the question that was related to decoupling the LabVIEW application from a web service. So basically, I could suggest to use a simply producer-consumer approach. So then it's very generic because you can transfer the text-based command to your main application, from which you may get back the response with the same mechanism, or post together with it a, for example, notifier, which you either expect or not to come back. And regarding the advanced features of web servers, well, you can also always have a wrapper like nginx, where you put some more advanced features, use some more advanced features of the web services, and they are just redirected to your LabVIEW web service, which is
Like load balancing or clustering.
exactly
maybe.
load balancing or some other stuff that you want to do.
We have a question here.
So this is regarding the question about can you use it with a different web server?
Mhm.
You would have to thunk it. You could use a different web server, but you would have to thunk through that to your LabVIEW app or your LabVIEW web service.
Yes.
You could do that if you wanted to, right?
Yes, yes.
And do you know anyone who's like run the LabVIEW web service thing, like on AWS? I mean, I know they have the system link thing from NI, but just this thing that you're building with the LabVIEW web services.
Yeah, so if you buy an AWS Windows VM, then you can just put your LabVIEW web service application.
Right, yeah, like on DigitalOcean. I think that's the better deal.
With that, sorry?
DigitalOcean?
DigitalOcean?
Yeah, I think it's cheaper than Amazon.
Okay.
Like if someone wanted to experiment doing that, you can get a VM from them or run a bunch of VMs or whatever.
Okay.
Okay, but
yeah, it's not something I really experience. I run most of my web services, or pretty much all my web services, on Windows servers, whether they are hosted in Azure, AWS, or just my own cloud infrastructure. But yeah, I usually stick on Windows for that. I never really had the need for other stuff. I'm a little bit a zombie in the LabVIEW ecosystem. I do accounting, project management software, etc. I hate hardware. I'm still an electrical and computer engineer, but I don't like doing what I've been trained for. So I do other stuff that I like more, and usually it's related to Windows applications, and in the end some desktop applications that just call some web services or web front ends. So I don't have much experience in hosting this in other operating systems, even RT.
Hey, Matthias, just to answer that question that he was talking about, it doesn't matter what web service you buy the machine images from. So you can use DigitalOcean or Amazon AWS or whatever you want to, as long as the image that you're spinning up is a Windows machine,
Exactly.
you can run it on
Exactly.
that image.
Just to add one thing to that, so you can basically host your web service with the UI that you want to share in any web service available globally, but then just exchange the data with the LabVIEW application with the WebSockets. So we have approaches like that, and then you can also have it in a Docker container, as well as.
But you need to solve a problem, because I believe you make something simpler more complex using that approach. So you need to have some problem that you need to fix. If you can just go with LabVIEW Web Service, you build that and you put that on the Windows machine, I mean, fine, that's the easiest way to go through. Then if you're having some issues, there are probably some alternatives like you mentioned, Piotr. Is there any last question? Okay.
Yeah, my question is not about the web services, but more
Okay, so next.
API, more about API design.
Yeah.
When you have an error on the server side and you want to send the details to the client, do you usually send, for example, the LabVIEW error string through in the payload, or do you use HTTP header for this?
So the answer is I never send the LabVIEW error string. And that's why I have error logs on the server. So I usually send like a 5.0 something internal server error.
Only HTTP code?
Only
but
HTTP
never...
code. No, I send in the payload. I have a JSON cluster which has error and reason.
Okay, so
So
payload.
just to have a little bit of description, but I usually never send the LabVIEW error code or description. Then I go look on the server logs to get more information. But yeah, if I can give a little bit information to the client, like the main reason of the error and the reason I do it, so that's the VI that you saw that I use in all my web method VIs. That's what it does. It takes a cluster that has so I have a library with all my potential HTTP errors that I reuse even across projects. And it's not very, very detailed. Again, if I need more details, I go into the server logs.
Okay, thanks.
So Alan or Sam, you can fight. We will have fun to watch that. Oh, there is one question up there. Yeah, you asked from the beginning, yeah.
Yeah, I think you kind of touched on this, but what was the logic of using cookies over a session ID?
So so you mean a session ID that you will create your own session manager, for example?
So a cookie, for example, you've got to store it on the client side, so you've got to deal with password protecting encrypting any passwords you've got on there. You've got the issue of legislation with using cookies on browsers these days in Europe. So with a session ID, you can store all that on the actual server side and just be posted to the session ID.
I usually develop my front ends using G-Web development software because I'm a G programmer. I don't know much about JavaScript and PHP and all that textual languages. So I found out that cookie for me was the best way to go from one web VI to another web VI while maintaining some state on the server, because you don't want the user to re-enter its credentials every time they go from one page of your application to the other application. And the nice thing with cookies is that the web browser, it's built in the web browser feature, it's going to send the cookie ID with each request as soon as the cookie has been created. So that works well for what I do with GWeb development software. But my API works both with cookies or a session ID that is passed using the headers of the requests. It's the same. My API works with both. You can use one method or the other. Of course, if I use GWeb development as the front end, it's going to use the cookies. If I do another LabVIEW API, maybe to communicate with my web services, I probably use the session ID in the headers.